Hello, this is MEI Further Maths Core Pure. We're in the first vectors section and on the third and final video on the angle between two vectors. You can watch the video straight through, but you will probably find it helpful sometimes to pause the video and try things out for yourself before continuing to watch. In the last video, we found two equivalent forms of the scalar product. A dot B, where you multiply the components of the vectors together and then add them up, is the same as the magnitude of A multiplied by the magnitude of B multiplied by cos of the angle between them. We can rearrange this to find cos theta and then theta. So, we're asked to find the angle between these two vectors. We start by multiplying the components together to find the dot product in the original way. So that gives us 5 times 7 is 35 and 0 times 3 is 0. So that's just 35. We also need the magnitude of each vector. Well, the magnitude of A is just 5 and the magnitude of B is the square root of 7 squared plus 3 squared. That's the square root of 49 plus 9, which is root 58. Using our rearranged formula, we have that cos theta is equal to A dot B, which we worked out to be 35, over the magnitude of A, which is 5, times the magnitude of B, which is root 58. This comes out to be 0.9191. And therefore theta, the angle between the two vectors, is equal to 23.2 degrees. We can use very similar working in 3 dimensions. Pause the video while you try this one for yourself. OK, we'll start by finding P dot Q. So 2 minus 4, 3, dot minus 2, 1, 3. That's minus 4 plus 9, which is 1. Then we need the magnitude of P, which is root 2 squared plus 4 squared plus 3 squared. That's root 4 plus 16 plus 9, which is root 29, and the magnitude of Q, 2 squared plus 1 squared plus 3 squared. So that's root 4 plus 1 plus 9, which is root 14. So, substituting into my formula, I get cos theta is P dot Q, which is 1, over the magnitude of P, which is root 29, multiplied by the magnitude of Q, which is root 14. That's 0.0496 and gives us a value of theta of 87.2 degrees. What happens when A dot B is 0? Pause the video for a moment while you think about this. OK, if A dot B is equal to 0, then we have that the magnitude of A multiplied by the magnitude of B, cos theta, is equal to 0. Now, assuming that neither A nor B are 0, because if they were, the whole thing would be rather boring, we have that cos theta is equal to 0. And that means that theta is 90 degrees. So, if A dot B is 0, then A and B are perpendicular, assuming that neither is 0. This gives us a very quick and easy way of finding out whether vectors are perpendicular to each other or not, especially useful in 3 dimensions. So, have a look at these. So, let's consider the first vector. We do the dot product with the vector A, so 2 minus 1 minus 3 dot 1 minus 1, 1. That gives us 2 plus 1 minus 3, which is 0. So this first vector is perpendicular. Pause the video while you check the other 3. OK, checking the second one, 2 minus 1 minus 3 dot 3, 0, 2. That gives us 6 plus 0 minus 6, which is 0. So that one's perpendicular as well. Let's try the third one. 2 minus 1 minus 3 dot 5 minus 1, 3. That's 10 plus 1 minus 9, which equals 2. So that is the vector which is not perpendicular. Because this is effectively a multiple choice question, we'll just check the last one to make sure that we haven't made any mistakes. So 2 minus 1 minus 3 dot 2, 1, 1. That's 4 minus 1 minus 3, which is 0. So yes, the other 3 vectors are perpendicular, and the only one that isn't is 5 minus 1, 3. Pause the video while you try this one. If A and B are parallel, then A must be a scalar multiple of B. If A is equal to minus 2 lots of B, then we have that minus 2, 3 is equal to minus 2 times 1k. And therefore that 3 is equal to minus 2k, which gives us that k is equal to minus 3 over 2. If we want A and B to be perpendicular to each other, we need the dot product to be 0. So minus 2, 3 dot 1k is equal to minus 2 plus 3k, and we need that to be equal to 0. That means that 3k must be equal to 2 and k must be 2/3. For our final example, we need to draw a quick sketch to make sure that we've got everything labelled correctly and we're going in the right directions. We want the angle ABC, so we need B at the point and A there and there. If that's the angle in our dot product, then these vectors must either be both going in or both going out. So that means that I need the vector BA and the vector BC. So this one's A, this one's B, this one's C. If I'm going from B to A, then I'm going from 3 to 2, that's minus 1. From 1 to 3, that's 2. And from minus 1 to minus 2, that's minus 1. Then if I'm going from B to C, I'm going from 3 to 10, which is 7. From 1 to 5, which is 4. And from minus 1 to 0, which is 1. If I now do the dot product, that gives me minus 7 plus 8 minus 1, which is 0. So the vectors BA and BC are perpendicular. So the angle ABC is a right angle. There are more notes on integral or in your textbook on the angle between two vectors. That's the end of this short video and the end of this series.